There's a number that seismologists in southern Spain do not like saying out loud because once you hear it, you cannot stop thinking about it. 348. That is how many times the ground beneath Granada has moved since the early hours of last Friday. Not once, not twice. 348 separate tremors recorded by Spain's National Geographic Institute in under a week. And the strange part is not that the earth moved. Granada has always moved. The strange part is that it has not stopped. This is the story of an earthquake sequence that refuses to follow the script. It began quietly, the way these things almost always do. On the night of August 14th into the early hours of August 15th, a moment magnitude of roughly 4.8 to 5.0 struck near the town of Alhendín, just south of Granada City, at a depth so shallow it startled the instruments reading it. 10 kilometers down by some estimates, some readings put it shallower still. For context, that is close enough to the surface that the shaking arrives almost undiluted. There is no deep rock to soften the blow. What starts below reaches the streets above almost exactly as violent as it left. People felt it as far away as Madrid. Cars were damaged by falling debris. Residents were pulled from stuck elevators. And then, instead of the aftershocks tapering off the way textbook seismology says they should, the ground kept talking. Over the following 3 days, the tremor count climbed past 300. Most were too small to notice. A meaningful number were not. That is where this story could have ended. A swarm, a scare, a return to normal. Except then came Tuesday, August 18th. At 10:37 in the morning, local time, with tourists in the streets and the summer heat already settling over the city, the ground moved again. This time, the epicenter sat near the municipality of Gojar, a short distance south of Granada's historic center. The National Geographic Institute logged it at magnitude 4.8, matching, almost precisely, the opening shock 4 days earlier. It was, officials confirmed, the strongest tremor of the entire sequence so far, and it was not alone. Within roughly 90 minutes, 3 more significant quakes followed, a 4.0 near Arenas del Rey, and 2 more in the 4.2 range striking Alhendín again, the same town hit hardest days before. Vice President of the regional government, Antonio Sanz, confirmed that 3 people suffered injuries, one of them a child who was taken to hospital. Around 50 calls came into Andalusia's 112 emergency line, most of them reporting cracked walls, fallen masonry, and landslip damage across the province. Here is where the story stops being a weather-adjacent curiosity and starts being something people in Granada have to actually live inside. Because the most photographed building in the city had to be evacuated. Staff at the Alhambra, the 900-year-old Moorish palace complex that drew over 2.5 million visitors last year alone, moved quickly to empty the Nasrid palaces and the Alcazaba fortress, the oldest and most delicate sections of the entire site, so specialists could check for structural damage. Tourists who had booked timed entry months in advance were walked out mid-visit. The rest of the complex stayed open for a time, under close watch. So why is this happening? Why now? And why does it keep going instead of settling down the way these sequences usually do? The short answer sits roughly 40 kilometers beneath everyone's feet, where 2 of the largest tectonic plates on the planet, the Eurasian plate and the African plate, are grinding into each other at a pace of a few millimeters a year. That sounds negligible until you remember the scale involved. Slabs of crust, hundreds of kilometers thick, pressing against one another continuously for millions of years, with nowhere for the pressure to go except into the rock itself. Eventually, the rock cannot hold what has been stored inside it. It slips, and Granada shakes. This collision has carved an intricate lattice of active faults through the basin the city sits in, faults that are, geologically speaking, still young and still restless. It is part of why the Sierra Nevada mountains overlooking the city are still slowly rising, by roughly a millimeter a year, according to researchers who study the range. Slow by any human clock, relentless by any geological one. What makes this particular sequence unusual is not the magnitude. 4.8 is moderate, not catastrophic, by any global standard. It is the persistence. Swarms in this region typically flare and fade within days. This one, as of Tuesday night, was still producing its strongest shock nearly a week in. And that single fact is what has scientists choosing their words carefully, rather than simply telling the public to go back to. That is not the full story, though, because the question everyone in Granada actually wants answered is not why did this happen? It is this over? And on that point, the scientists studying the sequence are being unusually honest about what they do not know. Mercedes Fariche, who leads seismic risk assessment work at the Andalusian Institute of Geophysics, put it plainly this week. Researchers are not yet certain whether Tuesday's quakes are simply aftershocks radiating out from the original August 15th rupture, or whether a separate, adjacent fault has been jolted into activity on its own. That distinction is not academic. If this is a straightforward aftershock sequence, the physics is on the public side. Aftershocks decay. They get smaller, less frequent, further apart, until the ground goes quiet again, usually over weeks. But if a neighboring fault has been triggered independently and is now releasing its own stored stress, the sequence stops behaving like a predictable tail and starts behaving like its own event, with its own uncertain ceiling. Nobody is saying a larger earthquake is coming. Nobody can say that. But nobody is ruling it out either, and in seismology, that gap between we expect this to fade and we cannot promise it will is where public anxiety tends to live. This is where the pattern turns dangerous. Not necessarily the shaking itself, but where it is happening. The clustering of this week's epicenter sits south and southwest of Granada City, threading through Alhendín, Gojar, Churiana de la Vega, and nearby towns, almost all of it at depths between 2 and 10 kilometers. That shallowness is the whole ballgame. A magnitude 4.8 earthquake at 60 kilometers down barely registers as a curiosity. The same magnitude at 5 kilometers down turns into cracked facades, falling masonry, and streets. Closed because chunks of centuries-old buildings are landing on the pavement below. Geologist Manuel Regidor, a former president of Spain's official college of geologists, told reporters this week that nothing about this episode is geologically abnormal. And from a strict scientific standpoint, that is true. This is what an active fault system does. But normal, in the geological sense, is not the same as safe, in the human sense. Those two words are doing very different jobs in that sentence. And it is worth sitting with the difference for a moment because it is the entire tension running underneath this story. To understand why officials are not simply shrugging this off, you have to look at what this same stretch of ground has done before. This is not the first time the Vega de Granada has rattled like this. Between late 2020 and 2021, the region went through a major seismic crisis. Of its own, thousands of tremors recorded over months with 5 separate quakes reaching magnitudes between roughly 4.1 and 4.5. Researchers who studied that swarm afterward concluded something reassuring. On the surface, the ruptures had been confined by the surrounding fault network, which kept the sequence from escalating into something larger. The geology itself acted as a kind of natural break. But confined is not the same as harmless, and it is certainly not a guarantee written into the rock for next time. Go back further, and the historical record turns considerably darker. In 1954, a magnitude 7.8 earthquake struck near Granada, a number that sounds almost unbelievable next to this week's 4.8s. It caused no real damage and no casualties because its origin point sat more than 600 kilometers underground, far too deep to translate into meaningful surface shaking. It is a strange kind of good fortune, an enormous release of energy that never had the chance to reach anyone. In 2010, a magnitude 6.3 event followed the same pattern, powerful at depth, harmless at the surface, because distance from the source blunted what arrived above ground. That is the difference between ordinary and dangerous in this region. It is almost never about the raw number on the seismograph. It is about how close that number's origin sits to the people standing above it. A shallow 4.8 can crack open a street. A deep 7.8 can pass by almost unnoticed. Understanding that distinction is the single most useful thing anyone watching this unfold from outside Granada can take away from it. And that is exactly why officials responded to Tuesday's quake the way they did, not with the muted caution of a minor tremor, but with the regional government's seismic risk plan moved to active operational status, building inspectors dispatched across the city overnight, and additional police patrols added through the following days. It is a response calibrated not to the size of Tuesday's shock alone, but to the accumulating pattern behind it. A pattern that, 4 days in, still had not shown the clean, predictable decay that would let anyone exhale. The forecast, if you can even call it that in seismology, does not end there. There is a broader piece of this region's geological story that reaches out past Granada's city limits, entirely, into the sea, and into a much older, much larger question about what this stretch of the Iberian Peninsula has produced before. The flood threat on the back end of this storm system is the dimension that will persist longest and may affect the most people who are not currently under fire evacuation orders. Excessive runoff may result in rock, mud, and debris flows in and near active fire. Perimeters, steep terrain, and poorly drained urban areas with the main impacts expected from Wednesday afternoon through Friday. The burned areas north and east of Reno now cover tens of thousands of acres of terrain that will funnel water and debris downslope with very little resistance. Canyons and drainage channels that carry water slowly in a healthy landscape become high-velocity debris corridors after fire of this magnitude. Neighborhoods that sit at the base of burned slopes or adjacent to drainage channels that originate in the burn scar face a threat that does not require them to be inside the fire perimeter. The water finds its path downhill regardless of where the evacuation zone boundary is drawn. If you are downstream of any burned terrain in northern Washoe County, you need to understand your drainage and your elevation before this afternoon's storms arrive. For those who have already evacuated, the message from officials is clear and consistent. Do not attempt to return to evacuated areas before receiving official clearance through the Washoe Regional Emergency Information Center. Law enforcement patrols are actively monitoring evacuated neighborhoods. Road closures remain in effect across multiple corridors. State Route 446 is closed in both directions through the Pyramid Lake area. Red Rock Road between Moya Boulevard and American Flat Road remains closed. Lemon Drive at Ramsey Way is closed. The mandatory evacuation route for the Winnemucca Ranch Road area runs southbound on Pyramid Highway only. These closures exist because the terrain inside them is either actively threatened, actively burning, or being used for firefighting operations. Entering closed areas does not just endanger the person who enters. It diverts law enforcement and emergency resources from protecting the thousands of people who are following the orders. There is another wrinkle here, and it is one that seismologists studying this region raise carefully because it is the piece of the story that turns a local news item into something worth genuine attention. South of Granada, between the coast of Andalusia and Morocco, sits the Alhambra Sea, a stretch of water that happens to sit directly inside the same collision zone, driving everything happening on land. Some researchers have pointed to this offshore area as a potential source of larger seismic events, capable of sending strong shaking into cities along Spain's southern coast, Granada included, even though the epicenter itself would sit out at sea. It is not a prediction. It is a standing possibility that keeps this region on seismologists' watch lists, independent of whatever a given week's swarm is doing. To understand why Granada shakes, you have to understand what is happening directly beneath southern Spain, because the forces involved are not small, and they are not new, and they are not going away. Right beneath Andalusia, two of the most massive tectonic plates on the planet are engaged in a slow, grinding collision that has been underway for millions of years, and will continue for millions more. The African plate and the Eurasian plate are moving toward each other, accumulating stress along the boundary between them, and that stress does not sit quietly. It builds into the rock. It travels through the crust, and periodically, in ways that cannot be fully predicted, it releases, sometimes gently, sometimes in ways that shatter buildings. The region around Granada is not a simple fault zone. It is a zone of distributed deformation, meaning the stress is not concentrated in one clean line the way it is along something like the San Andreas Fault in California. Around Granada, the forces are distributed across a dense overlapping network of fault structures running in multiple directions, some parallel, some intersecting, some feeding stress into each other in ways that make the system genuinely difficult to model. Alhendín, La Zubia, Gojar, Ogijeres, and Otura all sit within the Granada metropolitan area, historically classified as one of the highest seismic hazard zones on the Iberian Peninsula. That classification is not based on speculation. It is based on the measured geometry of the faults themselves, on their lengths, their orientations, and what those physical dimensions tell geologists about the maximum earthquake those structures are capable of producing. And the history of what these faults have produced in the past is not comfortable reading. On Christmas Day, 1884, the region was struck by the Arenas del Rey earthquake, estimated at approximately magnitude 6.7, which killed around 1,200 people and caused damage to more than 3,000 buildings across Granada, Malaga, and Almeria. The shaking reached intensity levels of 9 to 10 on the scale. That is the kind of intensity that does not leave a building standing. That is the kind of event that reshapes communities for generations. And 1884 is not ancient history. It sits within the living memory of living memory. It happened on these same fault systems that are moving right now. Going further back, a 1431 earthquake south of Granada, also estimated near magnitude 6.7, reached intensity scale 8 to 9 and caused significant damage across the region, including damage to the Alhambra itself. The palace that tourists are photographing this week, the one that UNESCO has designated as a site of World Heritage, it has been shaken before by events of this magnitude. And it will, in the geological long run, be shaken again. But the more instructive comparison for what is happening right now is not 1884 or 1431, it is 2021. Because just 5 years ago, the same general area around Granada went through one of the most remarkable seismic swarms in modern Spanish history. Since December 2020, a total of 281 shallow earthquakes hit the area around Granada, of which 8 had a magnitude of more than 3.0, and 41 were felt by the population. Spain's National Geographic Institute described the seismic activity as common for this area, flagging it as one of the most seismically active regions of the Iberian Peninsula. experiencing numerous surface earthquakes of low to moderate magnitude and occasionally with significant intensity. That 2021 swarm produced thousands of individual events over weeks. People in Granada went to sleep every night, not knowing if they would be woken by another tremor. The anxiety was cumulative, relentless, and deeply wearing on the communities involved. But the largest earthquake in that entire extended sequence only reached magnitude 4.4. What is happening right now is already larger. The main shock on August 15th, 2026, reached magnitude 5.0 to 5.2. That is already beyond the peak of anything the 2021 swarm produced. And that comparison matters, because it tells you that this current sequence is operating at a higher energy level than the last major episode Granada experienced. The epicenters are in a slightly different location. The possible fault geometry is different. And the question of whether this sequence will behave like the 2021 swarm, meaning extended and gradual, or whether the energy will dissipate more quickly following the main shock, is something scientists are actively analyzing right now with every aftershock that registers on the network. The 2011 Lorca earthquake in Murcia provides a sobering reference point. It had a moderate magnitude of 5.1, but resulted in 9 fatalities. The fact that the August 15th Granada earthquake produced no confirmed fatalities at a comparable magnitude is a significant outcome, and it speaks to improvements in building standards, to the speed of the emergency response, and perhaps to the specific characteristics of where and how the energy released. But it does not mean the geology beneath Granada has become any less capable. The fault systems are still there. The African and Eurasian plates are still moving. The stress that was not released in this event has redistributed along the surrounding structures. And the official monitoring apparatus knows this, which is why the emergency phase remains active and why the seismic network around Granada is watching every single event in real time. That possibility gains weight when you look back at the darkest chapter in this region's seismic history. On Christmas night, 1884, a magnitude 6.7 earthquake struck the province of Granada. The timing may have saved lives. Many residents were outdoors celebrating rather than asleep inside buildings that would soon come down. Even so, historical accounts put the death toll above 1,000, with thousands more injured and thousands of buildings destroyed or seriously damaged across an area that felt the shaking as far away as Madrid and Valencia. It remains one of the deadliest natural disasters in Spain's recorded history, and some researchers, studying its origins, have linked it to the same broader tectonic environment that includes the Alhambra Sea. Then, in 1956, a smaller but still serious quake near Albolote killed a dozen people and destroyed hundreds of homes, partly through the landslides it triggered. None of this means Tuesday's magnitude 4.8 is a preview of 1884. It almost certainly is not. Sequences like this one have, historically, stayed confined rather than escalating. But it is why officials in the region treat every swarm with more seriousness than the raw magnitude numbers alone would seem to justify. This is a province where the geology has, twice in recorded history, translated moderate-sounding tremors into mass casualties. That memory does not fade quickly, even generations later. Back in the present, the visible impact of this week's sequence has been considerable for a set of earthquakes that, individually, sit well below what seismologists consider catastrophic. Beyond the Alhambra's precautionary closure of its most fragile sections, one of Andalusia's largest shopping centers, the Nevada complex in Armilla, was evacuated as a precaution, with shoppers and staff moved into the outdoor parking areas while the building was checked. Granada's metro system introduced speed restrictions, slowing trains to a crawl while crews inspected tracks and tunnels for damage. Several streets in the city were closed off entirely after inspectors flagged the risk of falling debris from older building facades, a warning residents were told to take seriously, avoiding walking close to exterior walls in the affected zones. As of this week, not a city in crisis, not a disaster unfolding in slow motion, but a city that has been reminded, sharply and all at once, of something that was true the entire time it wasn't thinking about it. That one of the most beautiful, most visited places in Europe sits directly above the seam where two continents are still, slowly and indifferently, pushing into each other. If you're watching this because you're planning a trip to Granada, or you live somewhere else along this same fault system, the takeaway is not to panic, and it is not to dismiss it either. It is to watch how the next several days unfold. If the tremor counts keep shrinking, and the gaps between them keep widening, that is the sign this is behaving the way these sequences normally do. If a new, unrelated cluster shows up somewhere nearby, that is the sign worth paying closer attention to. Either way, the Andalusian Institute of Geophysics will know before anyone on social media does, which is exactly why officials keep steering residents back toward official channels. Granada has shaken before. It has gone quiet before. The historical record says both of those things are true, sometimes only years apart. What this week confirmed is that the ground underneath one of Europe's most photographed cities is still very much awake. And for now, that is the most honest thing anyone studying it can tell you.